Hussein. So in last session we have done, this what are the CCNA types of media and IC card and topology we have done, right?
Yes.
Now today we'll cover that numbering system, IP addressing, and IP addressing and subnetting we'll do by tomorrow. Today we'll discuss about this numbering system, then OSI layer. Okay.
Okay.
So here is some port numbers are there. Numbering system means some numbers are there. Okay, what is the port number? Before that, port number. The port number is a channel of communication. A system can initiate multiple session with destination computer. Unique number is required to identify the session, which is called port number, right? So what is the meaning of this? So the meaning of this is like, we have a multiple PC. Let me run this application first. Okay, so we are having multiple PCs which are connected in this. Let's suppose this is a switch. Under this switch, we are connected one PC, okay, and the router, okay, and like internet, okay. So like that is the normal scenario. PC1, okay, with the IP address 10.0.0.1. PC2 with the IP address 10.0.0.2. Let's assume that. Okay, so PC1 is trying to communicate with the PC2. Okay, so based on what this PC2 will understand that why that PC1 is requested for me. What is the the type of request? How it will be identified? This will be identified based on the port number only. Okay, like port number means like we are using www.google.com, right? So
Yes.
www.google.com. So at that time, if you're hitting enter, okay, automatically the HTTP or HTTPS and colon and forward slash will come, right? Like that,
Yes.
correct?
Yes. Yeah.
So
Correct.
we are trying to reach Google with the port number with this service by using this service, okay, HTTP. So HTTP is using a port number 80, okay.
Yes.
In the same way, if you're trying to access the through the web browser by using a HTTPS, again the port number is segregated with this HTTPS. That is the port number is 443. Okay, so these are the scenario that's the reason when PCs know like why the request is came. Okay, this that Google will understand that okay this the request has come for that HTTP, then they are looking for that a web browsing. Okay.
Okay.
Got it. So we are having a two protocol, that is HTTP and HTTPS. HTTP is not secure. HTTP is a more secure. Okay, that we will discuss in upcoming session. Okay, so port number is a channel of communication. A system can initiate multiple session with destination computer. Unique number is required to identify that session, which is called port number. Okay, port number is a 16-bit value. What is the bit? What is the byte? What is the KB? What is the MB? I will discuss later. So you just remember that the port number value of the port number, or we can say the size of the port number, like HTTP or like 443. The value of this port number will be the 16-bit. How that will calculate later. Okay.
Okay.
Range is start from 0 to 65,535. The port number is having some limitation. Okay, that is 0 to 65,535. Got it? So
Okay.
some port numbers are known, and this port number is divided into three part. Okay, just a minute. So these port numbers are divided into three parts. Okay, we can say a well-known, registered, and dynamically. Okay, dynamically means automatically assigned, and well-known means already registered. Okay, like HTTP, HTTPS, Telnet, SSH, everyone using their port number, right? So for HTTP, there is we said like 80 and port number, Telnet 22, SSH 23, like that. We are having a port number. Okay, so well-known is 0 to 1023. These are the reserve, we can say, like reserve also we can say. So 1024, and these are the registered and dynamically assigned from this range to this range. Whenever the PC is initiating any communication from another PC, that port number will be dynamically assigned from this one. Okay.
Okay.
Okay, so this is a port number and how it is used, that Okay, destination port is used to identify the service of the session at destination computer. Source PC will randomly randomly, choose any port number, and it will send it, and it will based on the port number it will reply. Okay, the meaning of this sentence.
Okay.
So these are the port number, like port number, TCP, transmission control protocol. Okay, and we are using a 20. Okay, FTP, that we are using a TCP with FTP process name. For the FTP data, if you're using FTP file transfer protocol for the data transmission, that this time it will take as a port number 20. FTP it will take as a TCP, file transfer control. Okay, and 22 is for SSH and 23 is for telnet. Okay, and 25 is for SMTP, simple mail transfer protocol, which is used for the email services. Okay, DNS port number is a 53, and that this is using DNS is work under the protocol TCP and UDP. Okay, every protocol is working under the either the TCP or either the UDP. All or the protocol, this TCP and UDP both is work under the IP protocol. Okay, that we will IP addressing. Got it? So this is
Yeah.
the root. IP, under IP everything will work. Okay, like TCP, UDP, both will work under this IPs only. Okay.
Yes.
Okay, so like TFTP, HTTP, POP3, NTP, IMAP, HTTPS, this kind of we are having this services with the port number, and every services is work under the particular protocols. Either this will work at TCP, otherwise it will work at UDP. What is the difference between TCP and UDP? I will explain you the transmission. I will explain you in upcoming slide. Okay, so open system interconnection, OSI layer. Okay, so have you heard about this?
Yeah.
So the open system interconnection is developed by the International Organization by the OSI, we can say, International Organization of Standardization and Introduction in 1984. Okay, it is layered architecture consists of 7 layers. Each layer defines a set of functions which takes part in a data communication. What is the meaning of this? Let's suppose you are in Vizag, okay, and you are one of your friend is staying into the Hyderabad, okay, and you are sending some courier to your friend. Okay, so first what let's suppose you wanted to send some book. Okay, so book is your data, right?
Yes.
Book will be your data, right? So to cover this book you required some box, right?
Correct.
Top of this box you will mention your the sender name, like your name, and the top of the box also you will mention the receiver name, right? And their address, your contact number, and the receiver address, receiver contact number, details, addresses of both the sender and the receiver. Got it? Correct?
From to.
No, no, from to, right? From means you are the initiator, like you're a sender. To means
Okay.
receiver, who is going to receive, right? Correct? So book is our data, and under one of the box you are just keeping that book under one of the box, and this box you're mentioning from and to. Okay, in the from you are mentioning your address, and the sender will be your receiver address. Okay, so these are the way how we are sending any how we are doing the courier from one location to another location, right? So what it will be happen, first step what you have done, you collected a book, you you cover you kept inside in the any of the box that book. Okay, so this is the way. After that you have mentioned, this is the layer, first step, second step, third step. Okay, then you booked someone is come, or you went to the courier office, the courier person giving you a confirmation slip that we received, and this any expected date of delivery, everything they are sending, right? They everything they are sharing details with you, correct?
Yes.
Yeah, at the same time one PC is connected here. Okay, and the one PC is connected here. Okay, both are in the same organization, both are connected under the switch. Okay, so this PC address is IP address is 10.0.0.1. This PC IP address is 10.0.0.2. Okay, this PC, yesterday we have heard about the MAC address, right? MAC address, NIC card. Let's suppose the MAC address of this
Yes.
PC is a.
Yes.
Okay, So A. So this is a source IP. Source IP. This will be a source make. Okay. So what kind
Okay.
of data they are sending, like HTTP, okay, or telnet. Let's suppose this is doing a telnet, okay. So source port will be telnet is using a 23 port number, right? Just now we just now we checked it, right?
Yes, yes.
So
23
in
telnet.
23, okay. After that, destination port. Destination port will be question mark, it may, okay, if it is already communication has been happened, then destination, let's suppose if the switch is no, then it is fine. If the switch don't know, let's suppose this piece is make address is a B, okay. So A and the destination will be a B, okay. So packet will be like this, packet will become like this, okay, and it will send to the PC. PC will check. Okay, PC will work like mediator, like a courier person for you. This switch will work like that, and the switch will check the request has coming from 10.1, which is connected to the fast Ethernet 0 by 1. This interface. Okay, okay, these details I'm having. Who is the sender? But I don't have a the this MAC address, the B MAC address. Okay, who is the destination MAC address? Let's suppose there is multiple PCR connected. Okay, so this is a B and this is a C and this is a D. Okay, the MAC address of this PC. When this switches don't know about this destination address, what switch will do? Switch will do the broadcasting. Switch will send packet to this one also, C1 also, and the D1 also. Okay, but C and D will check the request is coming for the B. They will check that, they will open the request, they will open this packet, okay, and they will discard, they will not reply to the switch because they don't have a no, make address B, right?
Yes, yes, yes.
So only B, again, so B will check open, and B will, what will do? B will reply that I am a B. Switch will again entry that that details. Okay, this fast Ethernet 0 by 3, this port number fast Ethernet 0 by 3. Some one PC is connected, that PC's MAC address is a B. Okay, now again it will send to the packet. Okay, so
Okay.
so this is the way how the system is getting to connected. Okay, got it.
Yeah,
So
yeah.
this is only described on the this one, our OSI layer. Okay,
Yes, yes.
this the process is described under the our OSI layer, how the packet is generating and how the packet is sending from each, from the source to the destination. Okay,
Okay.
so this is the way, like layer 7 is our application. Okay, application. Layer 6 is if you talk about the, if you read about the from the bottom to top, it is a bottom to top only, because layer 1 is always media. Let's suppose this is a media. Let's suppose this side also a application layer. Okay, this side also a presentation layer, this side also a session layer, this side also a transport layer, this side also a network layer, this side also a data link layer,
Okay.
this side also a physical layer. Okay, same layer are using. Okay, so this is the PC and this is the PC. Just assume both the physical are, means physical means cable, whether it is on cat 5 cat 6 or any cable can be. Okay, which is using into the networking, like it's generally we are using HTTP cable. Okay, so when these both are connected physical, sender will do. Okay, sender will send the packet, it will come to the presentation layer to the session layer to the transport layer to network layer, network to the data to physical. Once the physical layer receive the packet from top to bottom, and it will send to the via cable. Okay, if it is in a fiber cable, then it will send packet based on the light form. Okay, if it is a copper cable, then it will send on a electric form. Okay, so the based on the type of cable, it will modify their signal. Okay, so once this PC is received, what it will do, it will open first. We as a sender, as a courier, we are keeping safe everything, right? But here it will open first layer, then second layer, then it will remove the box and everything, and then it will receive the your book, right? Like that, this side everything will be separating. Okay, separating means everything will be going to be covering. Okay, and this side everything will be open. Okay, so
Okay.
if you to remember this, we have an application layer, presentation, session, transport, network, data, and physical. Now, what is the responsibility of each layer that we are going to discuss? Okay, so that's first this top three is known as a support layer also or software layer also. Okay,
Host layer
after
like.
this is the software layer. Okay, then this last three is known as a network support layer or hardware layer. Okay, this fourth transport layer is known as a core layer of the OSI. Means this network this transport layer is having a more responsibility as compared to this and this. Okay,
Okay.
so what is the application layer? It is responsible for providing an interface for the users to interact with application server or network service. Example: web browser, HTTP, telnet, etc. Let's suppose you are you are sitting in front of your laptop, and the laptop you're typing some this is in the screen in the browser you're typing www.facebook.com. So what the application layer is helping you to interact you. You are a human, right? And you are sitting here and you are just running you're just typing onto this, right? So everything, it is you and the PC are getting interact, right?
Yes.
So application layer will do like this. Okay, web browser http based on that service, it will hit. Okay, so overall we can say it is responsible for providing an interface for the user to interact with any application services or network services. Okay, then later second one, it is responsible for that presentation layer. It is responsible for defining a standard format to the data. So application layer is sending packet to the presentation layer in a raw material, right? In the raw format. So raw format, the responsibility of presentation layer is that it is to identify exactly the type of data. Okay, whether it is JPG, whether it is a MP4, whether it is a text, whether it is a voice, it will be identify this. Okay, presentation layer. Got it?
Yeah. Yes, got it.
Then it will encrypt also, and it will compression also. Encryption matlab ciphertext like ABC is a data. Okay, so encryption means it will has in some Chinese language, right? No one can read that. Okay, for the sender side. Okay,
Okay.
then compression means it will, the size is a 2 MB, then it will try to merge it and it will try to cover it in a 1 MB. Okay, compress. Okay, this is the sender side encryption and the compression. Receiver side, it will decrypt and decompress. Okay.
Okay.
So session layer, it is responsible for establish, maintain, and terminate the session. Session ID is used to identify a session or interaction. Okay. Like these are the protocol which is using by RPC, SQL, ASP, Apple Talk, session, and multiple. These three protocols are using for the session. Like session means what? Like you are having some function in your home. Okay. So you give an order to some caterer. Okay, some catering company, and they're coming, they are arranging everything. Okay, food and your stage and everything, right? Once once that function is over, they will again come, they will keep clean everything, and they will try to return back. Okay, they will get back, correct?
Yes.
So
Yeah.
once the work is done, they will keep back everything, right? So let for in terms of technical, let's suppose I'm just what I'm trying to do, I'm just copying. Okay, I'm doing here in this first step. Okay, in this browser first step, I'm just copying it google.com. Okay, google.com. Second tab, I'm typing a facebook.com. Okay, in third one, I'm typing in a youtube.com. In this one, I'm using in a WhatsApp. So how these are coming? Why this Google is not coming to this tab, and why this YouTube is not coming to the not opening under this tab? Because I hit it into this one, right?
Yeah.
I hit it into this tab. So
After.
who will be the responsible on this? So the responsible of this is a session layer. Due to this session layer only, we are taking an exact output in any single browser with a multiple tab. Got it? Clear,
Yes.
na?
Yeah. Clear.
Uh,
Clear.
okay. So later, it provide data delivery mechanism. This transport layer is having a huge responsibility. It provide data delivery mechanism between the application and the network. The major function described at the transport layer are identifying the service. Identifying the service means what kind of service is that, multiplexing and demultiplexing, multiplexing and demultiplexing. Multiplexing is, I will explain you, segmentation, sequencing and reassembling, error correction, and the flow control. What are these? Identification of the service. Let's suppose this is a, sorry. So let's suppose this is an HTTP. Okay. So it will identify, okay, it's a HTTP. Multiplexing will be, it will multiplexing from the sender side. Okay. Multiplex. How to explain that? I will explain it later. Okay. Multiplexing. Segmentation means it will break. Let's suppose the packet is coming 10 mbps. Okay, 10 mb packet is there. Okay, so it will break in a 10 pieces, 1 mb, 1 mb, 1 mb, 1 mb, 1 mb. It will segment because the cable is not that much of capable to or your interface, your network is not that much of capable to handle this much of payload. Okay, like 10 mbps of data at the same time. So it is breaking the packets and it is segmenting the packet one by one, bit by bit. It's sending and it is sending. Okay. Once it is sending, that sequencing this side. Again, it will breaking and it will sequence like this. Suppose one first 1 MB is the first, second MB is the second. Okay, third MB, first MB, first third is the third. Like that, it will sequence in the numbering system. Okay, it will keep sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, finally it is over payload. Okay.
Yes.
Error correction means if suppose the receiver is received and the receiver has received first, second, third, fifth, sixth, seven, eight, nine, 10, but this was not received by the fourth one. Okay, so it will send the packet to the sender. Okay, it will send a message to the sender that I received 1, 2, 3, 5 to 10 but not received the 4. So the responsibility of it will send the message again. Again the sender will send the message with the correct one. Okay,
Okay.
this is not going to, we are not going to this is not visible. It is the process how the data is sending from one PC to the another PC, whether it is in the same network or whether it is out of the network. Okay,
Yeah.
then error correction and the flow control means like the 10 mbps speed. If the sender is having a 10 mbps but the receiver is having a, let's suppose, 2 mbps of speed, so it will check the flow, the based on the receiver capability it will send again on that their flow. Okay, clear?
Yeah. For okay.
Any question on this?
No. Yeah. I know.
Multiplexing, I will. Multiplexing is not a big deal. What is that? I just it's completely out of
But
mind now.
transport name, some other name is there. I forgot that name. Some exactly name is there. Correct.
No, these 7 layers are only there.
Okay. 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 I mean. Okay. Okay. Okay.
If you're having any doubt, you can still ask
N-
me.
No. 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 Yeah. I know these things. So okay. No. Yeah. No. I can.
No problem, right?
No
So
problem.
after
Yeah.
that, it's sent to the network layer. Network layer, it provides logical addressing and the path determining. The protocol what work is this layer are on IP, IPX, Apple talk. Okay, routed protocol used to carry user data between host, RIP, OSPF, etc. Routing protocol perform path determination and routing. Okay, so what is the meaning of this? This, let's suppose PC is having a 10.0.0.1 connected with the switch, and it is connected with the another PC which is having 10.0.0.2. Okay, so and this it provides logical addressing. Logical addressing means IP is a logical address and the MAC address is a permanent address. Okay, the
Okay.
address of, let's suppose, the MAC address is called as a permanent address, IP address is
It is
called as a
permanent.
logical address. Sorry.
Yes. 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 Sorry.
Yeah. Okay. And addressing and the path determination, it is finding the path where, let's suppose, it is a router, not a switch. Router, then it is a router. It is, and router to, how to say? Just a minute, brother. This is not a correct example. So this is the router to the switch. Okay, and again we have a one more router, one more interface, one more switch. Okay, this interface we are providing a 10.0.0.1. This interface we are having 11.0.0.1. Okay, both are like considered as a private IP. Okay, this PC is using a 10.0.0.2. Gateway will be a 10.0.0.1. This PC will use a 11.0.0.1 and the gateway will be 11.2 and the gateway will be 11.0.0.1. Okay, so this is the PC and this is the address of this PC. Okay, so it will, whenever we are using this the router is a networking device. Okay, layer 3 device. In this we will configure some protocols like RIP, OSP, APDC. Every protocol is having their own functionality to determine the path. Okay, to find the path, to how the best path, the way of finding the best path is a different as per their characteristic. Okay, so it's sent to the packet and it come to the router knows about this 11.11 dot address. If it came from this interface, it need to be go by this interface, and switch will come, it will check the MAC address, it will send to the particular PC. Okay, so route RIP or OSPF PTC, these are in routing protocol, and router is our L3 device. Okay, which is just learn our IP addressing. Okay, IP header. Whenever you're sending like source IP 10.1, destination IP 10.2. Okay, then again source make, destination make. Okay, source port, destination port also there, like uh, source port, destination port. Okay, so IP is a our, this will become called as a IP header. Okay, which can be read by the routers only, which is a L3 device. Source make and destination make is our L2 address, which can just learn by the switches. Okay, like the switches. Okay, this destination and the source port and destination port will be our layer 4. Okay, layer 4 address. Okay, which can be learned by the firewalls. Okay, and some routers also. Okay, so address is also based on the layer, and every device cannot read every address. Like IP address cannot read by the switch, and this MAC address cannot read by the router. But if the switch is coming with the multi-layer switch, which is having nowadays capable to learn the to perform the routing also and the switching also. Okay, routing and switching both can perform. So this kind of switch can learn the MAC address also as well as IP address. Clear?
Yes,
Is
clear.
it done?
Yeah.
Okay. So after that, data link, it has a two sub data link like MAC address layer 2. Okay, make media access control. It provide reliable transit of data across physical link. It also provide error detection using CRCs, means some algorithm they are using to check the error detection. Okay, example Ethernet, token ring, this kind of the old technology which was used. Okay, nowadays Ethernet or the fast Ethernet or gigabit Ethernet only we are using. Okay, LLC logical link control, it provides communication with network layer. Okay, so after that, because the communication between network and this side and this side. Okay, this is the way. Then after that, physical layer. Okay, like that the connectivity is there. Okay, it then it came to the physical layer via cable, it come to the another PC, it will again do the same process. Okay, to receive the data. Got it?
Yes.
So this is the physical layer. It define the electrical, mechanical, and the functional specification for the communication between the network devices. The function described at this layer are encoding, decoding. Okay, it is the process of converting the binary data into signal based on the type of the media. If it is in a copper cable, copper media, then it will send the packet in the electrical form. Okay, electrical signal. Then the fiber, if it is in fiber, then it will send in the light form. Okay, if it is a wireless, then it will send in the radio frequency. Okay, once the data is received from the application presentation session network and this data and received on the physical link. Okay, physical, then it will be based on the cable type only, it will be work. Okay, it will change their format, data format. Got it?
Yes.
Yeah, so that is about the OSI layer. And now today we are again there is another form of this is the TCP and TCP IP. So this is also developed by DoD, Department of Defense. Okay, US Department of Defense. It was developed, created the TCP IP reference model because it wanted a network that could surely any serve any condition. Okay, So some of the layer in the TCP/IP model have the same name as a layer in the OSI model. We can say OSI layer and the TCP layer both will work together and both are launched together. Okay, but this was TCP and IP was already tested by the US Department of Defense during their that time 1984. And so if you are using for the same work multiple protocol, then there is a chances to fluctuate, right? So what they decide, we just keep OSI layer as a reference model, and for the real time we will use the TCP/IP. Okay, so instead of keeping a 7 layer, they kept it in just a 4 layer. Application layer is one of the you know layer which is working for the application presentation in the session. All three responsibilities taking care into TCP/IP by the application layer only. Rest are the same. Application presentation session, then transport, then network, then it is a physical network access is called the physical layer. Okay.
Okay.
So application layer handle high level protocol issues like this. Okay, application, which kind of application they is using. Then transport layer, then internet, then the what are network access is using like DNS or internet is using for the SNMP, telnet, or login. This kind of protocol they're using. Okay.
Okay.
Then transport layer, five basic service segmentation. Upper layer application data establishing end-to-end operation, sending segment from one end host to another end host, ensuring data reliability, providing flow control. So transport layer is also whatever that responsibility in that OSI layer. In the TCP as IP also having a same responsibility of the this transport layer. Okay.
Okay.
Segmentation, upper layer application data, establishing end-to-end operation, sending segmentation, ensuring and providing a flow control. Okay, so these are the way internet layer. The purpose of internet layer is to end packet from a network node and have them arrive at the destination node independent of the path token. Okay, so internet IP, internet protocol, internet control message protocol, that is the ICMP. ICMP, like where we are sending some, we are for the reachability purpose we are pinging, right? Like ping dot 10.0.0.1. So this is work under the ICMP. ARP is used for the address resolution protocol. When that when the switch is don't know about the receiver MAC address, then that time this ARP is performing. Okay, and ARP, reserve address resolution protocol. Okay, that is for RARP, that is for address resolution. Okay, both are work for the same address resolution only. Got it? Like how it work means, how it works means like this is on a switch. Okay, this is a switch and PC is connected, both the PC are connected here, and both the PC is with the MAC address A with the IP address 10.1 with the IP address 10.2. This PC don't know about the 10.1. Okay, this PC don't know about this B MAC address, so it will broadcast. Okay, by using the A, it will broadcast and it will send the packet. Like when it is don't know, then ARP will function. ARP will come in the picture to help to resolve the address. Okay, this address, the MAC address or the IP address. Okay, so these are some logical behavior of any PC to finding the addressing or resolving the addressing, that we are not doing anything. It is an internal activity that they are doing by themselves. Okay,
Yeah.
so after that network layer, the network access layer is connected with all of the issues that an IP packet required to actually make a physical link to the network media. It includes the LAN and the WAN technology details and all the details contained in the OSI physical and the data link layer. What is the meaning of this? So here Ethernet, fast Ethernet, SLIP, FTD, ATM, these are the old technologies. ARP, proxy ARP, RARP, these kind of services working on the network access layer. Okay.
Hmm. Okay.
And then comparing the OSI model and TCP. So these are the comparison. Like application is having four layer only, and that OSI is having 7 layer only. So these are the way. Okay.
Okay.
Similarities of the OSI and the TCP/IP model. Both have layers. Both have application layer through the including very different services. Both have compatible transport and network layer. Packet switch, not circuit switch technology is assumed. Networking professional need to know both the models. So what is the meaning of this? So both the layer, both have layers. Okay, whether we are talking about the OSI, this is having a 7 layer. TCP/IP
So,
is TCP/IP is having a 4 layer. Okay,
okay.
both have application layer. Okay, that application layer is having in the both. Through they include very different services. Okay, in OSI they are giving a different services. In TCP/IP they are having a different services. Okay, both have compared comparable transparent and network layers. Both are having both the layers. And packet switch, not circuit switch technology is assumed. Okay, packet switch or circuit switch it means both are supporting. Okay, different of the OSI and the TCP that you can read it. Okay, TCP/IP combine the presentation and the session layer into its application. It means there is no big difference on this. Internet architecture. That what is the architecture? To computer anywhere in the world following certain hardware software protocol. Protocol. Do you know about the protocol? Have you heard?
Yeah.
Protocol.
Yeah.
Protocol is set of rule, right? Which is predefined. If this protocol, let's suppose RIP is having is our network protocol, means this is a predefined the what is the work characteristic, what is the way of the finding the best path. Okay, which IP it will work for what, which IP it will work for what, like that. It is already predefined under this. Okay, so this called as a protocol. Specification can communicate reliability even when not directly connected. If both are different geographical network also, they will perform same protocol only. Okay, to communicate each other.
Mm.
Clear?
Yeah,
Whether it
clear.
is in India or UK or somewhere else, but the performance, the way of internet architecture is only that every device in the world which is running with the IP and the MAC address, they will follow the same protocol. Okay, that is the TCP/IP protocol. Okay,
Mm. Okay.
by using this by performing TCP/IP protocol only nowadays, we guys are able to use like this is a Dell PC and this is a HP PC. Before TCP/IP or OSI layer, there was nothing like that. HP is having their own protocol. Dell is using their own protocol. So if suppose you are using Dell PC in your network, so from top to bottom everything should be a Dell only. Then only everything can communicate. Here HP, then everything should be in a HP. Then only your system will running. Okay, but after bringing this, because both are using different language, let's suppose this is using a Chinese language, this is using Hindi language, both don't know, right? So there is no chance to be establish the communication. But if but when both the PC are using the same, either Chinese or here also Chinese, then both can be established, they both can understand their language, right?
Yes.
Manufacturer can be different, but the language is same. The language is nothing but is a protocol. Okay, so if the protocol is same, then the step communication can be established. Clear?
Yeah, clear.
Then TCP UDP. What is the TCP and what is the UDP? Like whenever that packet is sending from sender to receiver. Okay, this is a sender, this is a receiver. So when the sender is sending PC, there is a three-way handshake. We call as a three-way handshake. Okay, like you are meeting to some unknown person, you're traveling together, and after some time if you are start communicating with them, hi, how are you from, like that, you're asking, then you are asking, he's replying, then like that the communication is starting, right? So these are the way, like first sender will send is a sync packet. Sync means it will send a request, then it will send a sync with acknowledgement to the sender, the receiver will send, and after that it will send a acknowledgement again. Okay, means request is a sync, and sync plus acknowledgement is sending by the receiver, and the sender will sender will send again acknowledgement. Okay, UDP is user datagram protocol. Okay, so here we are having, okay, this packet has synced by in TCP sended. Okay, again it is sended. Okay, I received, then again it is okay, once this sender is sending a packet. Okay, a receiver has given the confirmation, the sync and acknowledgement, then again the sender will send acknowledgement. Okay, so whenever you are some, let's suppose you are having some relatives are there, and he came to your home, and after spending some day with you, he again going to his native place. You went to drop him at the railway station or the airport. Okay, he went. He take his flight and he went to his hometown. Okay, once he reached the hometown, he will send you the confirmation that okay, I reached to home, right? In the same way, if you're not getting any confirmation that he is that person has reached their hometown or not, then this is work as a UDP. So if there is a question like why, if it is TCP is giving a confirmation, then why we are using the UDP, right?
Yes.
So TCP, why we are using, we are sending a packet, okay, any data, then we require a confirmation. When we are talking together, like video conferencing, voice call, I'm having a good signal, you are not having a that much of signal strength, okay? So there is chances that our voice will break, but call will not disconnect, right? Is it? It's happening, right? When you are you
Yes,
when you
happening.
are when you were um uh, you are here and you are having a good signal, I'm here and I'm having a little bit low signal, okay? So with this good signal, what it will do, the like video call, conference call, everything, okay? Who is a presenter? I am a presenter now, as of now, okay? I initiated this meeting with you, and that if my network is good, then it will work fine. If your network is and connected, many people are connected in this meeting, but other candidates are also having good signal, but you don't have a good signal, right? So it doesn't mean that call will disconnect for others, right?
Yes, correct.
So that is the reason where we are using the user datacom protocol, where we don't need, here, receiver will send request, then response, then response, then response, but the call is not going to be disconnect. So in this voice call or video conference, we are using the UDP protocol, okay, where we are using some data sending, HTTP or other things. Then that time we are using the TCP, okay.
Yeah.
So these are the some keys about this TCP and UDP. Keeps track of lost packet. Makes sure that lost packet are resent. When any packet is or any service is working under the TCP, it will make sure that if the packet is lost, any packet is lost on, okay, so it will resend that the packet. UDP doesn't keep like that tracking, okay. Add sequence number to the package and recover and the packet that arriving to the wrong order. If it is not sequence, then it is also everything, it will keep track by the TCP, okay, but not like the TCP. Once UDP send the packet, that there is the responsibility is over from there, whether the packet is received by the user or not. It will not take it will not care of that.
Yeah. But
TC, hmm?
TCP
Tell
is
me.
the secure. TCP is the secured one, right? It will take some time, also some time, but definitely that is the secured one, TCP.
No, we can't say like just secure only.
Okay.
Security is a different part.
Okay.
Here, TCP and UDP, the main different. Whenever you are sending a packet, the once user is received, the receiver has received the packet. Receiver will give a one confirmation message to the sender that I received that packet. Okay, but UDP will not. UDP, by using some product, some services by using which is running under the UDP. Okay, it will not, the sender will send the packet, but once receiver send or not, they are not getting any kind of confirmation notification together, okay, in between.
Hmm. Okay.
Okay, so what are the protocols that HTTP, HTTPS, FTP, these are working on this HTCP, and these are the DNS, IP, telephone, DSCP. Many computer games are working under the UDP.
Okay.
Okay,
Yes. Yes.
like we are talking now. If you want, if I have, let me verify. If I am having a wire arc, okay, I'm
Voice
having a
okay.
wire arc, okay.
Yes.
So we are connected through which cable?
Oh, yeah.
I'm connected
Wireless.
with our wireless, okay.
Yes.
So whatever we are talking now, that the voice and the video, my system presentation will go via our, where it is. Let me identify Wi-Fi, okay. This one, right? So
Yes.
start capturing, okay. So UDP, whatever I'm talking now, it is an UDP. Are you able to see anything in the TCP? Nothing, right?
Nothing.
Nothing has been there. So everything is
Yes.
running on the protocol that is
Good.
the UDP because voice. Okay. So by this way we can verify that whether it is working on the UDP or TCP, UDP or TCP. Okay, so everything is working under the UDP only.
Okay. Yes.
If you check anywhere the TCP where I'm presenting something, okay, TCP is not there. Fine. So like that we can quick without saving. So we can verify that. So that's all. That's all for today. And we have completed today what we have learned about the numbering system, not numbering system. OSI layer we
OSL layer. Yeah.
done. Okay. And TCP IP also we have done, which I need to do. TCP IP, TCP IP done. Okay. And what we have done today? TCP and UDP, TCP and UDP, right?
Yes.
TCP
UDP
and
also.
UDP we have done, right? So these are the things which we have covered today. In upcoming session, we'll do a numbering system first. Okay, beat byte, what is the beat and what is the byte, like that we will cover that. And after that we'll go with the IP addressing, subnetting. Okay, then telnet is what is the
Okay.
router and switches that we will cover. Okay.
Okay.
Yeah, thank you for your time. Do you have any other question?
Yeah, that's fine. But one more question. I have one question.